Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So in this video, we are going to discuss about D flip-flop. So this video covers what is D flip-flop and the truth table, logic diagram of D flip-flop, and what is meant by characteristic and excitation table and equation of D flip-flop. Before enter into the topic, let us have a small recap about the previous video. So in the previous video, we discussed SR flip-flop. So S means set and R means reset. Yes, there are two inputs and one clock input. So in S flip-flop, there are four states: hold state, set state, reset state, and invalid state. So the invalid state, if both inputs are 1, that is high, if S is equal to 1 and R is equal to 1, the flip-flop enter into invalid state. So next we will enter into the today's topic. So why we need D flip-flop? That is the main empathy point is we need a D flip-flop to eliminate the race around, that is invalid state in the SR flip-flop. We use D flip-flop, and other empathy points are the D flip-flops are used as a memory element, and it can be used in counters, registers, and these are the main empathy points. The next is define, the definition of D flip-flop. So D flip-flop is known as delay flip-flop or data flip-flop. It has two input, D input and clock input, and outputs are Q and Q bar. So it can be either synchronous or asynchronous. And if the clock input is high, the data is transferred to the output of the flip-flop. When the clock input is low, the output of the flip-flop is held at its previous state. And this is the truth table of D flip-flop. So, if the D flip-flop input is 0, that is D is equal to 0, then the output will be 0. And if D is equal to 1, the output, that is Q, will be 1. The flip-flop changes its state at the rising edge of the clock pulse. So when the clock signal is high, the flip-flop samples and stores D input. And the characteristic equation. So why we need the characteristic equation? So the characteristic equation tells the behavior of the flip-flop for the different combination of input and current state. Here D is the input, Q is the current state, and Qn plus 1, or it can be represented as Qt plus 1 is the next state. So Qn plus 1 output of flip-flop at the next cycle. So D of n is the input to the flip-flop at the current clock cycle. So this characteristic equation of D flip-flop states that the output of the flip-flop at the next clock cycle will be equal to the input of the current clock cycle. So if D is equal to 0, Q is equal to 0, the next state will be 0. And if D is equal to 1, whatever the current state, the output will be same as the input. So 1, 0, the next state will be 1, and for 1 D is equal to 1 and Q current state is equal to 1, the next state will be 1. So using the K-map, we can derive the characteristic equation. The characteristic equation of D flip-flop is, that is Qn plus 1 is equal to D of n. The next one is excitation table. So excitation table is required to know what will be the input we should give to change the flip-flop from one state to another state. So here Q of n and D of n, using these two inputs we can say the next state. So if Q of n is equal to 0 and D of n is equal to 0, the next state will be 0. And for 0, 1 it is 1, and for 1, 1 it is 1. So there are 3 states: hold state, set state and reset state. So when Q of n is equal to 0 and D of n is also 0, then the Q of n becomes 0. It is called hold state. So when Q of n is equal to 0 and D of 1 is equal to 1, the next state will be 1. It is called set state. That is, set means 1. And when the Q of n is equal to 1 and D of n is equal to 0, so the next state is 0. So it is called reset state. And if Q of n is equal to 1 and D of n is equal to 1, the output is 1, that is it held at its previous state, that is hold state. This is the excitation table of D flip-flop. And this is the logic diagram of D flip-flop. It is derived from SR flip-flop. That is, in SR flip-flop, both inputs are given the same input, that is S is equal to R is equal to input. Here it is inverted. That is, here there are 4 gates are used. That is, the design of the D flip-flop consists 4 NAND gates, and the output is Q and Q bar. And this is the assessment time. The first question is why we need D flip-flop. Second question is write the truth table of D flip-flop. And the last question is write the characteristic equation of D flip-flop. And the answers are: D flip-flop is needed to eliminate the race around condition or invalid state in the SR flip-flop. Truth table of D flip-flop is when D is equal to 0, Q is equal to 0, the Q n plus 1 is equal to, that is next state is equal to 0, and when D is equal to 1, the next state also will be 1. Characteristic equation of D flip-flop, that is Q n plus 1 is equal to D of n. So thank you. Hope this video will help you to understand the basics of D flip-flop. Thank you once again.